When you flip a light switch, it feels like magic, but it's really science. Electricity travels an incredible journey to reach your home. It all begins at a power plant where energy from water, gas, or the sun is used to generate a flow of electrons, what we call electric current. This current travels through a vast network of wires known as the power grid, like highways stretching across the country. The grid connects power plants to cities, towns, and every home, ensuring electricity is always available when you need it. But the electricity on these high-voltage lines is far too powerful for your home appliances. To move electricity efficiently over long distances, engineers send it at very high voltage, reducing energy loss along the way. Once it nears your neighborhood, the voltage is lowered to make it safe for home use. So, next time you charge your phone or turn on a light, remember the journey. Electrons racing from a distant power plant across the grid right to your outlet. This process powers our modern world and showcases the marvels of science and engineering. All of it starts with generating that first spark of energy. Science is everywhere, even in the wires hidden in your walls. High-voltage electricity races across the power grid, hundreds of thousands of volts. But your devices can't handle that. Enter the transformer, a device that steps voltage up for long-distance travel, then steps it down for safe use. At the power plant, step-up transformers boost voltage, making transmission efficient and minimizing energy loss. After traveling miles, electricity reaches a substation, where step-down transformers lower the voltage for local distribution. The final step-down happens near your home. Look for a gray can on a pole or a green box in your yard. This last transformer reduces voltage to a safe level for your house. Thanks to transformers, electricity makes its journey safely and efficiently from the plant to your plug. Each step ensures the right voltage for every stage of the trip. Without transformers, we'd lose too much energy and risk dangerous power levels at home. It's a brilliant system that keeps our lights on and our devices safe. The journey of electricity is one of constant transformation, all so you can power up with a simple flip of a switch. The final transformer near your house does more than lower voltage. It creates split-phase power, the standard in North American homes. 3 wires come to your house, 2 hot wires and 1 neutral. Each hot wire carries 120 volts relative to the neutral, which is grounded for safety. The magic, the 2 hot wires are out of phase. When one peaks, the other dips. This means you get 120 volts between either hot and neutral, perfect for lights and outlets. But between the 2 hot wires, the voltage doubles to 240 volts. That's what powers big appliances like stoves and dryers. With just 3 wires, your home gets both 120V for everyday devices and 240V for heavy-duty machines. It's a clever, flexible system that keeps everything running smoothly. Split-phase power is why your home can handle everything from a lamp to an air conditioner, all thanks to a simple, smart design. The split-phase system is the backbone of home electricity in North America. Pretty cool, right? The 3 wires from the transformer, 2 hots and 1 neutral, enter your home at the main electrical panel, also called the breaker box. This metal box is the heart of your home's electrical system, dividing incoming power to all your circuits. Inside, you'll see rows of circuit breakers and 1 large main breaker at the top. The main breaker acts as a master switch, shutting off all power in emergencies or for repairs. The 2 hot wires connect to metal bars called bus bars. Each smaller breaker clips onto one of these bars. Breakers control individual circuits, bedroom outlets, kitchen lights, or the dishwasher. If a circuit draws too much power or has a fault, its breaker trips, cutting off electricity to prevent overheating and fire. The panel ensures every part of your home gets the right amount of power, safely distributed. It's a command center for your home's electricity. The main panel's design keeps your system organized and protected. Every circuit has its own safety switch. Modern electrical panels are critical for safe, reliable power. That's how your home stays powered and protected. Inside your main panel, the neutral wire connects to a neutral bus bar where all the white wires from your circuits return. The ground wire, bare copper or green, connects to a separate ground bus bar. The ground wire's job? Safety. It normally carries no current, but if something goes wrong, it provides a safe path for stray electricity to reach the earth. In the main panel, the neutral and ground bars are bonded together, linking your system to a grounding rod outside. This bond ensures your entire electrical system is referenced to the earth, protecting you from shocks. If a hot wire touches metal, the ground wire carries the surge safely away, instantly tripping the breaker. The neutral wire is the normal return path. The ground wire is the emergency backup. Together, they create a robust safety net. Grounding and bonding are silent protectors, working behind the scenes. This system is one of the most important safety features in your home. It keeps you safe from electric shock and fire. Every wire, bar, and bond has a purpose. That's real electrical peace of mind. The split-phase system gives us both 120V and 240V using the same wires. Inside your panel, two hot bus bars, leg A and leg B, and a neutral bar make it all work. Standard circuits use a single pole breaker, connecting one hot leg and neutral for 120V, perfect for lights and outlets. For big appliances, a double pole breaker connects both hot legs, delivering 240V. Some 240V appliances also need a neutral for controls or lights, so they get 4 wires, 2 hots, 1 neutral, 1 ground. This setup powers everything from your phone charger to your oven. Electricians design circuits to match each device's needs. The system is efficient and flexible. With just one service line, your home gets all the power it needs. That's the genius of split-phase wiring. One system, 2 voltages, endless possibilities. Let's see these circuits in action around your home. A lighting circuit starts at a 15-amp breaker, with a cable containing hot, neutral, and ground wires running to switches and fixtures. Flip the switch and 120V flows to the bulb, lighting your room. The neutral returns the current and the ground stands by for safety. Outlet circuits work the same way. For heavy-duty jobs like a clothes dryer, a dedicated 240V circuit starts at a double pole breaker. This thicker cable has 2 hots, a neutral, and a ground. The 2 hots power the heating element, the neutral runs controls and lights, the ground keeps everything safe. Matching the circuit to the job ensures efficiency and safety. Every device gets the right power for its needs. From lights to laundry, circuits are tailored for the task. That's how your home stays bright, comfortable, and safe. Smart circuit design powers your daily life. Circuit breakers are your home's first line of defense, protecting against overloads and short circuits. Overloads happen when too many devices draw power. Breakers sense the heat and trip before wires overheat. Short circuits, when hot and neutral or ground touch cause a surge, breakers trip instantly to prevent fire. But to protect people from shock, we need GFCIs, ground fault circuit interrupters. GFCIs monitor current flow. If even a tiny imbalance is detected, they shut off power in milliseconds, preventing electric shock. That's why GFCIs are required in kitchens, bathrooms, and outdoors. For fire prevention, AFCIs, arc fault circuit interrupters, detect dangerous electrical arcs from damaged or loose wiring. When an arc is detected, the AFCI trips, stopping a potential fire before it starts. Modern codes require AFCIs in many living areas for extra safety. These smart devices work together to keep your home safe. Breakers, GFCIs, and AFCIs are silent guardians. They make modern electricity safer than ever. We've followed electricity from the power plant to your wall outlet, learning how transformers, split-phase power, and safety devices protect us. Understanding these basics helps you appreciate the science behind your daily life, and reminds you to use electricity wisely. But remember, knowing how it works isn't the same as being qualified to work on it. Home electricity is powerful and dangerous. Mistakes can be fatal. Always leave electrical work to licensed professionals. Electricians have the training and tools to keep your system safe. Test your GFCI outlets monthly, and stay curious about the science around you. Respect electricity, and trust the experts for repairs or upgrades. Your safety is what matters most. Now that's powerful science in action.